Hello, this is our video tutorial on creating a binary adder. Today we're using our AdderVideo.1.mp4 development board and the Quartus 2 software kit. So if you have never installed the development board, if you've never used it on your computer, the first thing that you need to do is update your drivers so that it recognizes it. To do that, we're going to go into Device Manager. On this PC, we can just search for Device Manager. And since our computer already has the USB driver set up, it's not going to look the same, but your tutorial handout will have more clear instructions. So when you are in your device manager, you're going to be looking for other devices. Here, our development board is already underneath of our current USB controllers. And when you do open up the other devices and you do see a USB blaster, you can open it up and you'll get a window very similar to what we have here. And under driver, you can choose the path and directory name for the driver that you need. It should be all in the Altera folders that you downloaded as part of the software. So now that our computer sees the development board, we're going to open up the Quartus 2 software and use the new project wizard to create our first project. And it's a greeting window, and you'll see it when you first get there. And it guides you through the steps that you need to do. You need to create a directory for your project. You have to, name your project and also set the top level entity. And this is, if you're new to using the Quartus 2 software, perhaps you're familiar with this already, but when you do go to compile and implement your design, you may come up with errors that you did not, your top level entity is undefined. So just be cognizant of that. That is something that you need to declare in before you compile in order to get your design to successfully be synthesized. So now that we have our directory, the next step is to add any files that we want as part of our project that may be pre-existing. We also need to bring in our user libraries. So I'm going here to the user libraries, and by clicking on that, it will take me to global libraries. I can set any global or project libraries that I want, and in the Quartus 2 files under Altera 11.0 Quartus 2 libraries, you can select mega functions, and that entire folder is one huge library that you really need to get any of your Verilog code to compile. So make sure you get that, and once you've got that, you can go on and select family and device settings for our Cyclone 4E. That is the chip that we're working with, and you need to select it out of the options below, all the possibilities. That is printed in your tutorial handout. You can click next, and the final screen is you do not need to make any adjustments there. Summary, finish. So now that we have our new project created, we need to add some code to it. So we go to New, and we select a Verilog file under New, and then a new Verilog file will open, and we can insert our code. We obviously have written our code already, so we're just going to copy and paste that into our file. And you want to make sure to save it because it does not automatically save, and to save it under the same name as your project, as the top level entity. It'll make your life a lot easier. So for this project, we needed information on pin assignments, input-output standards for all of the signals we're sending in and out, and all of that information is in the DE2115 user manual. For example, here is the 7-segment display and all of the switches and their pin assignments. You'll insert those pin assignments by going to Assignments, Assignment Editor, and opening the assignment editor, and then inserting all your values and port names as necessary. For this tutorial, we'll just be importing some assignments that we've already made by going to Import Assignments and then choosing our file and importing that into the new file, which is our project for this tutorial. So in the future, you can use System Builder to select what hardware you're using, and it'll automatically generate all of your pin assignments. But if you need to do it the long hard way the first time around, this is what you're going to be doing. And for this particular project, you're going to end up with close to 200 pin assignments, because each of the pins that you're using does need two assignments. It does need the input-output standard, and it does also need the location. And like I said, all of that information is here in the Altera manual for DE2.1.1.5. Like, for example, here you see the pin assignment, but you also see the input-output standard. And like I said, we're going to be using the LEDs, the 7-segment display, and the switches, and also the LCD controller. So for the LCD controller, you will need more than the pin assignments. So you'll also be referencing the LCD data sheet to get information off of that on how to use it. In determining your code for the LCD controller, this data sheet is going to be your best friend. If you do need to send it 8-bit binary, this is the chart that you can use to determine each and every character that you want to display the upper and lower for. You will also need to reference the commands for the data bus, and also what signals need to be sent with RS and RW. And all of that information, including the initialization sequence that the LCD controller does need to go through in order to work, is all here in the data sheet. And just to note something that we came across as we were building this sequence does not say to turn on the display, but you do need to do it, as your intuition probably already told you. Just make sure to include that in your initialization sequence. So now that we've magically gotten our pin assignments and a little gnome magically created all of our code for us, we are ready to compile our design. And in compiling our design, we ran across an error, and that error was, as I mentioned to you, generated out of the top level entity not being defined. And this is a pretty common error when you are first getting started. We copy and pasted our code, but the module name was something different other than what the top level entity was. And so we just needed to go back in and redefine that. And now on the second go around, our code will hopefully compile. So we wanted to show you the full compilation process just to show the pretty standard timing that it takes for the design to compile. You can see in the lower left corner the progress in each of the steps. And it is, it's not going to happen right away. And if your computer's going slow, these computers are great and it still takes a while. So don't expect it to happen right away. Don't be afraid if it's not happening right away for you. And just as a note, you'll see lots of blue warnings pop up. It will still compile with warnings. Obviously, if you get an error, it's not going to compile, and you will need to double click on the error when listed here, and it'll take you to the place in your code where the error is being generated from. So you just saw the note that it was successful. We're going to go down to Program Device, and the Programmer window is going to open. Our USB hardware, USB blaster, is showing up. If it was not, you would select on Hardware Setup and select USB blaster, and then just close the window, and then it should appear. You're going to click the Start button, and you can watch in the upper right corner as it progresses through the synthesis. So this is just a snippet of what the end results will be when you've compiled and synthesized your design.